A strong foundation leads to a sturdy structure. This principle applies to buildings and it applies to data as well. Have you ever wondered how businesses organize data to make it easy to understand and use? The answer lies in data modeling. In this lecture, we will explore the basics of data modeling. We will also learn how it helps us organize data into meaningful relationships, understand schemas, and create robust data sets for analysis. In this lecture, you will understand what data modeling is and why it matters. Learn about relationships and data and how they connect data sets. Explore schemas and their role in organizing data. Data modeling is the process of organizing data so it can be used efficiently. It's like creating a blueprint for how data should be structured and connected. Without a model, data can become chaotic and difficult to work with. Think of data modeling as building a Lego structure. Each Lego piece represents a piece of data. Without a plan, the pieces are just pile of plastic. But with a clear model, you can build anything, a house, a car, or even a castle. Just like a Lego model needs a plan to take shape, data needs a model to become useful for analysis and decision making. Relationships define how different data sets are connected. One to one. Each item in one dataset corresponds to a single item in another. For instance, a person and their passport. One to many. One item in one dataset connects to multiple items in another. For example, a customer can place many orders. Many to many. Multiple items in one dataset connect to multiple items in another. For example, students and the courses they take. Understanding relationships ensure your data remains connected and accessible. For example, in a library system, relationship links books, authors, and borrowers, making it easy to track who borrowed what. A schema is like a map that describes how data is organized in a database. It defines tables, fields, and the relationship between them. Star schema, used for data warehouses with a central table, fact table, surrounded by related tables, dimension tables. This is common for reporting and analysis. Snowflake schema, an extension of the star schema where dimension tables are normalized into multiple related tables. For example, in a retail business, a star schema might include a central sales table with dimensions like customers, products, and time. This structure makes it easy to analyze sales trends across different categories. Robust datasets are essential for accurate and efficient analysis. To create them, normalize data, remove duplicate entries, and organize it into related tables. This reduces redundancies and improves efficiency. Ensure data integrity. Use constraints like primary keys, unique identifiers for each record, and foreign keys, links between tables to maintain accuracy. Document your model. Clearly define the purpose of each table and field, ensuring anyone can understand and use the data. For instance, an e-commerce company might create a dataset with normalized tables for customers, orders, and products. This ensures that customer information is not repeated unnecessarily, saving space and reducing errors. Design a simple data model for a school system. Include tables for students, teachers, classes, and grades. Define the relationship between them, for example, one to many or many to many. To conclude, we can say that data modeling is about organizing data into meaningful structure. We covered relationships, schemas, and how to create robust data sets for analysis. These principles are essential for managing data effectively and ensuring it supports business goals. What kind of data relationships do you find most interesting? Can you imagine a real-world system that uses complex relationships like a hospital or an online store? Share your thoughts in the comment section. That was all about this lecture. See you in the next one.